Hello class, this is Sir Kenny and welcome back to STM005 or General Chemistry 1. For today, we will talk about Module 13, which is calculating amounts of reactants and products. But before we begin, let us have our lesson objectives. By the end of the lesson, I can say that yes, I can write mole ratios relating the amounts of reactants and products in a chemical reaction. And yes, I can calculate the mass of a substance that is produced or consumed in a chemical reaction, given the mass of any other species involved in the reaction. Let us define stoichiometry. Stoichiometry is the field of chemistry that is concerned with the relative qualities or quantities of reactants and products in chemical reactions. Stoichiometry came from two words, stoichion meaning element, and metrion meaning to measure. So literally speaking, pag sinabi natin stoichiometry, it is the act of quantifying or measuring elements. Now there are two types of stoichiometry. Kagaya ng sinabi dito, we have qualities or we have qualitative chemistry which is identifying which elements or which substances are combining with the reactants to form products, and quantitative chemistry or the amounts of the reactants which will produce a certain amount of products in a chemical reaction. Next, we have stoichiometric equivalence. Stoichiometric equivalence means that a definite quantity of one substance reacts with a definite quantity of all the other substances present in the equation. An example of this is the equation 2 moles of hydrogen gas plus 1 mole of oxygen gas will produce 2 moles of water. Now, in this equation, we can say that the 2 moles of hydrogen gas is stoichiometrically equivalent to 1 mole of oxygen gas, and that these 2 moles of hydrogen gas is also stoichiometrically equivalent to 2 moles of water. Yun nga 'di ba, sabi kasi kanina na the definite quantity of one substance reacts with a definite quantity of all the other substances, given that the chemical equation is balanced. So, ibig sabihin, nakadepende ang ating stoichiometrical equivalence sa balancing ng chemical equation. Now, if you need a refresher on how to balance chemical equations, you can refer to our Module 12. Module 12 talks about how to balance chemical equations. I have included there two ways to balance chemical equations. The first one is using the trial and error method. The second one is by the use of algebraic expressions. Also in Module 12, nandoon din po ang how to determine the type of chemical reaction and how to predict the products. The contents of Module 12 are essential in studying chemistry. Hindi lang siya sa Gen Chem 1 pag-aaralan, kundi maging sa Gen Chem 2 din. So if you need a refresher, always go back to our modules and our video lessons in Module 12. Okay, going back. Now, itong mole ng oxygen, which is 1, it is also stoichiometrically equivalent dun sa dalawang mole of hydrogen gas at dun din sa dalawang mole ng water. And that the 2 moles of water here is stoichiometrically equivalent to the 2 moles of hydrogen gas and the 1 mole of oxygen gas. So that is what we mean by stoichiometric equivalence. Let us have an example. How many moles of carbon dioxide will be produced with 5 moles of octane or C8H18? Going back to our lesson in Module 12, this is an example of a combustion reaction wherein an organic substance will react with oxygen in the presence of heat to produce carbon dioxide and water. So this will be our chemical equation. This is our organic substance. If it reacts with oxygen, it will burn to produce carbon dioxide and water. The second step in order for us to determine the number of moles of carbon dioxide which will be produced with 5 moles of octane, we have to balance the chemical equation in order for us to determine the stoichiometric equivalence of the substances. After balancing the chemical equation, you have to get the given, which is the 5 moles of octane. Now, using the given and using the stoichiometric equivalence, we will be able to determine the number of moles of carbon dioxide. How so? Using this computation. So this is our given, 5 moles of octane. From our given, we will move to our stoichiometric equivalence. Ang mga involved na substances dito ay ang C8H18 at ang carbon dioxide. So, we have to get the stoichiometric equivalence of C8H18 and then carbon dioxide. So, in every 2 mole of C8H18, there are 16 moles of carbon dioxide. These two are interchangeable pero pwede mo siyang ayusin depende sa iyong kailangan. Now, in this case, ang given kasi natin ay mole of octane. Since given dito ang mole of octane, we have to arrange our stoichiometric equivalence na kung saan magiging same ang denominator sa unit ng ating given. So, dito, 2 moles of octane, ilagay natin sa denominator para makancel. And then, ilagay natin sa taas yung hinahanap, which is the carbon dioxide. So, cancel the units. So, 5 divided by 2 times 16, we will have 40 moles of carbon dioxide. This is the amount of carbon dioxide which will be produced given we have 5 moles of octane. Next, how many grams of oxygen will be used with 5 moles of octane? We are still referring to the combustion reaction here. So write down the chemical equation. Next is to balance the chemical equation. For the third one, hanapin natin yung given. Ang given naman dito ay 5 moles of octane at ang hinahanap natin ay ang grams of oxygen. Fourth one, let us get the stoichiometric equivalence and then compute. So there are two substances involved in this one, octane and then oxygen. So itong dalawa. Now, 2 moles of octane is stoichiometrically equivalent to 25 moles of oxygen. Ang given natin ay 5 moles of octane. So, kagaya ng sinabi ko kanina, this is interchangeable. Depende sa kung ano ang kailangan mo. Since ang unit natin dito ay mole of octane, our denominator should also be mole of octane. 5 moles of octane divided by 2 moles of octane, cancel unit, times 25. This will be equal to 6.25 moles of oxygen. So that is the amount in moles of the oxygen which will be used up in the chemical reaction. Pero ang tanong dito ay grams of oxygen. We have to convert mole to grams. In order to do this, we have to apply the rules in our formula here. Ang nawawala ay ang mass of substance. So therefore, ang matitira ay number of moles and then molecular weight. Since they are side by side, ibig sabihin multiplication. So, number of mole, 6.25 moles of oxygen times molecular weight. So 6.25 times 32, cancel mole, you will have 2,000 grams of oxygen which will be used up sa chemical reaction. Another example, how much in grams of water is produced if 50 grams of C8H18 is burned? Again, this talks about the same chemical equation. This is still combustion kasi this is still an organic substance. Kaya, write down the chemical equation. Next, balance the chemical equation in order for us to determine the stoichiometric equivalences. The third one is to get the given. Ang given natin ay 500 grams of octane. Ang hinahanap kasi natin ay ang kanilang stoichiometric equivalences. So in order for us to determine the stoichiometric equivalence, kailangan natin makuha yung moles. Kasi 'di ba, ang unit ng ating coefficient ay mole. So therefore, ang given natin ay dapat naka-mole din. So in order to get the number of mole, mass of substance over molecular weight. So this is the mass, this is the molecular weight, cancel grams. 500 divided by 114.26, you will be left with 4.376 moles of C8H18. Ngayon nakuha mo na ang given in moles. Next is to get the stoichiometric equivalence and then compute. Next, our given 4.376 mole of octane. Then our stoichiometric equivalence. Ang ating substances involved here are octane and water. So, ito yung octane, ito yung water. So, the stoichiometrical equivalence is 2 moles of octane is stoichiometrically equivalent to 18 moles of water. So itong dalawang gagamitin natin. Arrange that in order for our denominator to have the same unit as the given para makancel. So ganito ang mangyayari. So 4.376 mole divided by 2 moles times 18. Cancel mole of octane, you will have 39.384 moles of water. Ang hinahanap ay grams of water. So we have to make use of our formula. We have to make use of this again. So ang hinahanap ay ang mass of substance in grams. So magka side by side ang number of mole at molecular weight. So that means we have to multiply the number of moles with the molecular weight of water. So 39.384 moles of water times 18.02 grams per mole of water. Cancel ang mole, you will be left with grams. So this will be equal to 709.7 grams of water. So that means kung meron kang 500 grams of octane, ang mapoproduce na water ay 709.7 grams. So that's it for Module 13. Please work on your modules.